As the last section of this chapter, we will discuss the Doppler effect. The Doppler effect is the phenomena that when the source of the sound wave moving toward or away to the observer, the frequency of the sound wave that the observer hear will be different from the frequency of the sound wave at the source. Also, if we have a stationary source but the observer moves toward or away from the source, the observer will hear the different frequency of the sound from the frequency at the source. And the Doppler explain this using the fact that the sound wave move independently in the medium from the source. It means that once the source generates the sound wave will move away from the source, and after that it's independent from the source. Okay, so the speed of sound wave relative to the medium that we assume that it is at rest will depend on the property of the medium only. Okay, and now we have two situations. That is, if you have a sound wave, a source of the sound wave. If you have the source of the sound wave and you have an observer that moves toward or away from the sound wave, and we will have that the frequency of that this observer here is different from the frequency of the frequency at the sound wave. Okay. Next, we can also have the situation that the observer is stationary and the source moves toward or away the observer, and if the frequency at the source is F, we will have the different frequency at the observer. Okay, in this case also. So let's first discuss the situation that the observer moves according to the medium and the source is stationary. For example, in this figure, this person on the bike moves toward to the source of the sound wave that maybe stay still. This car is stationary. Okay. If the velocity of the sound in the air is v, Okay, so the sound moves away from the source with the velocity v, and the observer moves to the source of the sound with the velocity v0. Okay, with the velocity v0. Oh, sorry, vo, not v0, vo. The observer will see the same wavelength of the sound as the wavelength measured from the source. Okay, the wavelength is like the observer will see some length of the metal stick that moving toward or away from the observer. He or she will see the same length of the metal stick, but the velocity of the metal stick can be different. From when the observer look at the metal stick and when the people at the source look at the metal stick. Okay, so what we have, the information that we have now is that both the people at the source and the observer will see the same wavelength of the sound, but they have, or they see the different velocity of the sound. Okay, so according to the observer, if the velocity of the sound in the medium is v and the velocity of the observer is v0, and use the fact that the lambda, the wavelength of the sound, is the same for the observer and the source, the velocity of the sound as seen by the observer, if the observer moves toward the source, will equal to v plus v0. So the frequency of the sound that the observer hear, f prime, is equal to the v prime over lambda. V prime is the velocity of the sound that the observer hear. For the source, the frequency of the sound wave from the source is equal to the velocity of the sound wave in the medium over lambda. And from this equation we have lambda is equal to v over f. And since we say that lambda for the observer that move toward the source and the lambda that generate from the source are equal, so we can put this lambda to this point, and finally we have that f prime is equal to the v prime over v of f, or is equal to the v plus v0 over v of f. So you can say that if the observer moves toward the source, the frequency that the observer here will increase is larger than the frequency at the source. But if the source moves away, if the observer moves away from the source, okay, and if the observer moves away from the source with the velocity v, so you can use the same calculation to get that in this case the frequency that the observer will hear, f prime must equal to the v minus v observer over V of F. Okay, so these two equations give us the formula of the frequency that the observer will hear if he or she moves toward the source or move away from the source.